Okay everyone, my name is Rahmat bin Roslan. First of all, good morning to all of you. Today I will present for our assignment, which is for example 7. Okay, for the example 7, question A. Find the angle between the planes x plus y plus z equal to 1 and x minus y plus 3z equal to 1. From the question A, we want to find the angle between the two plane. Okay, from the first equation of the plane and the second equation, we can know the normal vector of those equation is number 1 is 1 1 1 1 and number 2 1 negative 2 and 3. To find the angle between the two planes, we use the formula, this formula, cos theta equal to n1 dot n2 over magnitude of n1 multiple with magnitude of n2. Then we just substitute the value of the normal vector to this formula. Then we get 2 over square root of 42. Then we evaluate this formula into this form. Then we can find the theta that between the two planes, that is 72 degree. This theta 72 degree. Okay, now we will continue to question B for the example 7. Okay, the question is find the symmetric equation for the line of intersection L of these two planes. Okay, from the diagram, we can see D is the first plane with the equation x plus y plus z equal to 1, and this is the second plane with the equation x minus 2y plus 3z equal to 1. So the line L is in the both plane, they intersect the both plane. Okay, to solve this equation, first we must find the point that lies on the line L. So we let z equal to 0, and then we just substitute on both equation. So we get the first equation, which is x plus y equal to 1, and second equation x minus 2y equal to 1. So we do the elimination step where equation 1 minus equation 2. Then we get y equal to 0. Then we substitute y equal to 0 in the equation 1 back. Then we get x equal to 1. So we conclude that the points on line L is 1 0 0. As we know, intersection L lies on the both plane. So it is perpendicular to the both of the normal plane. So we use the cross product to find the vector v that parallel to intersection L. So we use this formula. You just substitute the normal vector to this formula. So this is the first normal vector, and this is the second normal vector. So we solve it, and we get the vector v equal to 5i minus 2j minus 3k. So this question we need to find the symmetric equation. So we use this formula to find the symmetric equation. X minus x naught over a equal to y minus y naught over b equal to z minus z naught equal to c. So we substitute x naught, we substitute s equal to x naught is 1 over a is 5 equal to 1 minus y naught is 0 over b is 2 and negative 2 equal to z minus z naught is 0 over c is negative 3. So we solve it and we get x minus 1 over 5 equal to y over negative 2 equal to z over negative 3. So this is the symmetric equation for the line of intersection L.
Okay, good morning everyone. My name is Brilliant Sharon Norbert, and for my assignment for multivariable calculus, I'm going to present to you example 8, and this is my question. Okay, for example 8, the question is find a formula for the distance d from point P, that is x1, y1, z1, to the plane ax plus by plus dz plus d equal to 0. So firstly we need to draw the plane. This is our first point, that is P1, x1, y1, and z1. For these questions, we are not given the second point, because if we need to find the distance, we need 2 points, at least 2 points. Okay. For the second point, we assume that P0 is the second point, so we let P0, x0, y0, and z0. We put the point on the plane. So this is the distance that we need to find. N is equal to the normal vector, and B is the vector corresponding to P0 against P1. From the plane that we have drawn just now, we list down all the elements that we have, right? Firstly, the P1, x1, y1, z1. Second point is P0, that is x0, y0, z0. So B is our vector corresponding to P0 and P1. So this is the value after we substitute both of the P0 and P1 inside B. So this is the value. And for normal vector N, we just write A, B, and C. We can see that the distance D from P1 to the plane is equal to the absolute value of scalar projection of B onto the normal vector. In order to find the distance, so this is the formula that we need to use. So we just substitute the value for the normal vector and also the corresponding vector that we have listed down over here. So we just substitute. So firstly, A multiplies with x1 minus x0, and then plus with B, y1 minus y0, and then plus C, z1 minus z0, over square root of A to the power of 2 plus B to the power of 2 plus C to the power of 2. Okay, after we substitute, we will get ax1 plus by1 plus cz1 plus negative ax0 minus by0 minus cz0 over square root of A to the power of 2 plus B to the power of 2 plus C to the power of 2. Because of P0 lies on the same plane, so we can say that the equation for P0 is ax0 plus by0 plus cz0 plus d equal to 0. So we can also write the equation as d equal to negative ax0 minus by0 minus cz0. So if we see this equation or this form, it is the same as the other that we have found just now. So we just only substitute d to this value. So we will get our final answer is distance is equal to ax1 plus by1 plus cz1 plus d over square root A to the power of 2 plus B to the power of 2 plus C to the power of 2. Okay, that's all from me. Thank you so much.